Participants, we can move to our next session, that is on harnessing the quantum machine learning for IoT data insights. It's my privilege to invite Mr. Tushar Das to deliver this session. I hope, sir, you are here. Can you unmute yourself?
Okay, actually I was not going to unmute myself. Thank you. I'll just switch on the video also.
Yes, sir.
I hope I'm audible, right?
Yes, sir.
Okay, thank you.
So, Mr. Tushar, sir, is a seasoned global technology consultant and serial entrepreneur with over 25 years of experience across the US, APAC, South Africa, and India. As an IoT solution architect and Industry 4.0 specialist, he has successfully led large-scale digital transformation initiatives for top organizations like Accenture and Cisco. His work has delivered groundbreaking automation solutions across diverse industries, including logistics, agriculture, healthcare, and real estate. In South Africa, Mr. Tushar sir played a crucial role in building local technology delivery capabilities, establishing a solid foundation for technology-driven business growth in the region. As an entrepreneur, he has founded and scaled multiple business practices and centers of excellence, achieving remarkable revenue growth and fostering strategic innovation on a global scale. He is deeply committed to education, dedicating significant time to training engineering students and corporate teams in IoT and Industry 4.0. His effort equips learners with the skills required to excel in the rapidly advancing world of connected technologies. By bridging the gap between cutting-edge industry trends and practical applications, he inspires the next generation of tech leaders. A dynamic speaker and consultant, his unique blend of global expertise and passion for driving innovation make him sought after leader in the technology space. We are honored to have him with us today to share his insights and expertise. Thank you so much for accepting the invitation, sir.
Thank you, Dr. Shilpa. Really, it's an honor for me to be with such a privileged set of people who are doing. Okay. When I look across all of you, I can always understand that, okay, you guys may have gone through a lot of things on quantum computing and everything. And as it is just evolving, what I'll try to put forward today is not for everyone just to set that expectation. I will not talk about a lot about what you can the stories of quantum computing, how it is going to change, how it is going to revolutionize the entire thing, because I believe all of you have already understood that over the last few days whenever you have been part of this particular communication, part of this subject presentation. Okay, what I will try myself that I will just walk you through that when we talk about a specific technology of Internet of Things, how we visualize that what are the impacts it can bring into the immediate side, into the what you can say like forthcoming in the next 1 or 2 years and into the future. So basically immediate, nearest time, whatever you consider, and the long term. So my entire presentation will be primarily to talk about that, okay, at this particular moment, when we talk about IoT, there are certain myths, certain these things like when we talk into the software layer or primarily from the software side, from the IT side, when we look into IoT, we have got certain myths in our mind, and unless and until you break that myth, going forward, just bringing in quantum computing, all these advanced technologies may not be simply a plug and play for IoT. Okay, so just to cut it short, let me open my presentation. This presentation will be mostly, I've just created certain slides based on to my thought process. You can always ask me if something is not very clear. You may not have to wait till the end. If something you need to understand before that, you can ask. But I'll try to talk mostly about certain factors of IoT at this moment. What are the challenges we are facing? And then I'll try to connect that when we get into the era of quantum computing, how practically it can resolve. So I will not talk about technology into quantum computing, but yes, certain aspects of this technology, how at present it seems that in IoT it can help us. Okay. So please bear with me for a couple of things as I may have to refer with a couple of notes here and there and all this. Okay, I'm sharing everything onto the same screen and all this. Sometimes it becomes an issue. Okay, so I'll try to share my presentation first. Give me a moment for that. Dr. Shilpa, if I need any help, you may have to help me. I'm just trying to.
Yeah, I'll be here only, sir.
Sure. So I'm just trying to share the screen first so that I can just check all of them. So here I think here share content, right?
Yes.
To a presenter. Okay, here. Okay. I'm just trying to figure out where it is because there are so many files.
Yeah, you can select the window which you want to share.
Okay. I'm just not getting that entire thing. Webex meeting. Okay, here one may go. How will I know? So I don't know if
Yeah,
what
it
is
is
that I'm
been
showing
shared.
right now. No, but I just wanted to share this one. Just give me a moment because like it's not just like on any other Microsoft application or something. So it's just taking me a little bit. And for everyone, I really apologize. Give me 2 minutes so that
No
I
problem,
can just
sir. No problem.
set it up.
Yeah.
So actually, the ma'am, I've just puts one of my PPT into full screen mode, and I'm trying to search it out when I'm trying to share the content. Okay, but I'm not getting it. I don't know why.
First, select the PPT, sir. After that, we can switch to full screen mode.
Okay. First, select the PPT. Okay.
Yeah.
Okay. Now I've selected the PPT, right? And then I just go there and go for the
No, after selecting the PPT, you can click on the share button.
Right. That is showing a different PPT. Just a minute. Is there any PPT the shown in front of you?
Yeah, it is there, but it is something.
Just not that same thing. No, something else.
Yeah, something else.
There are some notes I had, so that's why I think it was giving it. So here, if I close all other things, will that help? I just want to, just a minute. I just have only 2 PPTs here. Okay, now. It is giving me the option of sharing Microsoft PowerPoint, 2 of them. Okay, and now I think I can get it.
Yes.
Yeah. Now if I
click on slideshow. Yeah.
Click on slideshow. And if I move into any notes or anything, will that still work?
Yeah, that will work.
Just a minute, let me try.
If you are particularly selecting this window, it will be not working, I think so.
Perfect. So now you can see my screen, right?
Yes, sir.
The PPT.
Yes, sir.
Okay. Fine, we'll go back there. Okay. As I was just setting it up, okay. So whatever we are going to talk today or everything, like what this entire absolutely revolutionary technology is going to impact, how it is going to impact, how it is going to help us, how it is going to change the things, the way we do and everything. That is what we are trying to get now. So let me move forward. I think I can move on to this. Okay. So when we talk about quantum computing as a whole, we all understand that we are moving from a limited capacity in a very, very simple terms. So I am using simple terms because there is a reason for that. And anytime if you have any queries, anything, please let me know, stop me. So what I'm trying to say is that when I look for the specific technology of quantum computing, there are 3 areas where I believe at this particular moment, it can give us a significant benefit. Yes, there can be much more into the future. There can be much more beyond that. But when you talk about IoT, there are certain transformative potential. And there are 3 primary areas. I will talk through this. But one is from the classical computing, when you are moving into quantum computing, all of you know that we have already, you might have discussed a lot about it. But when we talk about IoT, you know, there is something I would like to talk that in IoT, we don't even follow the basic rules of classical computing. There are a lot of changes onto that. And that's where a lot of people, when they use IoT, the progress of IoT, the advancement of IoT has got slowed down because we tried to implement, tried to get the advantage of IoT, tried to get the benefit of IoT and everything without understanding that even onto the classical computing side, we were not there. IoT is a little bit different when we talk about architecture, talk about hardware, talk about communication and everything that we'll talk about. Then when I look into a couple of things, we'll talk about in IoT, we all talk that there are security is an issue. And I can see a straightforward thing. Will not deep dive into the technology a lot because there is not much time today, but I'll just give you certain ideas which you can further deep dive for your, because all of you do a lot of research and everything. But I'll give you the pointers where we are working at this particular moment when the customers are asking us, what is that going to change into IoT side immediately in the next, you can say 1, 2, 3 years in that particular timeline. We see security and optimization is another big block. I'll come to that. So security and optimization is one. The first one why I made leap beyond classical computing because I will challenge a little bit onto that. Then the security side, yes, drastic changes can happen. Whatever we are facing the issues of security, I don't think immediately with this quantum computing we can resolve everything. But yes, there is a lot of things happening on that area. Then definitely optimization is one of the area where is data optimization, or you can say data distribution across different layers, you know, like I'll come to that. So data distribution optimization we'll talk about. And definitely one of the things is data analytics. But on the third point where I would like to tell, everybody talking about analytics, everybody talking about machine learning and the advantage of that, we all know that. But when we talk about IoT as in a perspective of IoT, data analysis and machine learning is not the core component, but the value component of IoT. It collects. So IoT's main thing is to get the data, massage the data on certain aspects on certain what you can say like physical areas where it is collecting till the time it sends the data to the cloud. Majority of the IoT's what you can say like technological requirement aims. But when we talk about an end-to-end application, when we talk about an use case, we definitely IoT's use case, IoT's value comes from data analytics, machine learning, predictive analysis, all these things. So there definitely quantum computing is going to help us. Instead of, in fact, waiting here, let me move forward. There are a couple of things I would like to talk before I talk about quantum computing. I have seen always wherever I'm going, especially in India, outside it is a little bit different, but in India it's more, we are very good into the software layer. We try to solve everything through the software layer, and we are very good onto that. The primary thing whenever I go to anybody, client, to the teachers, to the students and everybody, they ask like, what are the languages we're using? How fast we can make things happen? Okay, why the security is a problem? Okay, why can't we use, in fact, fire and security encryption protocols and all these things? Where we fail drastically is to understand that IoT or the IoT networks are not like other IT components. I think a lot of us, whoever is present here, also might struggle if I say that in the world of IoT, there are two components. One is IT, another is OT. So this entire technology, whatever we're implementing for the world in the name of IoT, IIoT, digital transformation, smart factory, in fact, Industry 4.0 and all this, we are basically entering into an era which is called OT or operational technology. So always there is a clash between IT and OT. IT people with their software knowledge and everything, they try to solve things without understanding OT side, without understanding the challenges of OT. Now I'll just come to this few of them. When we suppose, for an example, when you talk about this, in fact, quantum computing, we are thinking about much more faster computing, much more faster processing, much more, in fact, capable computers and everything. But just imagine a couple of things. When we talk about IoT, we don't even talk about i7, we don't even talk about an i5, we don't even talk about a powerful laptop. We talk about microcontrollers. We talk about systems which runs on battery power. The systems which runs with maybe 64 kilobytes of memory, maybe in today's world 4 to 8 MB of memory is also coming into a lot of development boards and everything. So when we are actually working, actually developing, actually giving things onto those areas, thinking or bringing in a very advanced computing into that environment itself is a myth. We call it the 5 P's that constraint of IoT. One is power. Definitely, we normally talk about battery powered devices. You cannot imagine like you just implement certain IoT solutions on a, what you can say, like on a moving truck, to put some IoT solutions onto oil rig. You put some IoT solution into the deserted areas or to the desert on your on infrastructure or something. You are not even getting a proper electrical power. You are looking into devices which can run 5 years on a simple battery, which in your mobile phone also, if you see the kind of applications we have, kind of computation power we have in today's world, with all the things what IoT needs, like communication like Wi-Fi, communication like Bluetooth and all these things, with all these things along with the power, your mobile doesn't survive more than 1 day. When we are talking about IoT devices, we want to make it survive for maybe minimum 6 months to 6 years. Imagine we are putting an IoT device in a busy street where a lot of parking the things are happening. We have got use cases and everything, and you have got devices below the road where the devices need to survive for the next 2-3 years before that battery can be changed. On that context, when we talk about, forget quantum computing, when you talk about normal computing, we cannot really do the same processes, same technology, same approach into that device. Next is, when I talk about processing of data, majority of the IoT devices, I'm telling you, is still cannot take even video data. When we talk about primarily, if there are billions of devices at this moment in the world, I think not even 10% gets that high, in fact, processing data, real-time video data, real-time audio data kind of things. It's basically, it has got limitations on processing. Then definitely the place where you are putting it, it is not secured places, it is remote places and all this. You cannot imagine bringing a simple concept of your quantum computing, of that level of computing into those kind of geographical places or location. It's impossible. It can never happen. If not today, I don't know what will happen after in the next 20 years, I don't see that. But another biggest factor is the price. When we implement IoT, is basically getting the data from the source, sending the data to the cloud, and then we try to process. But those data, whenever we are trying to get those devices, remember that we are very price sensitive. Let me tell you a simple example, a couple of examples. For example, when we talk about IoT-driven cars today, and every car in India also, when we are talking about it, smart cars, smart data elements, all these things are coming up. So when you have a 20 lakhs car, or suppose 10 lakhs car, or suppose 1 lakh rupees bike, on that also we are enabling IoT. We are getting the data. We are actually doing actuation. We are doing some kind of analysis. We are making it perfect and all this. But a 1 lakh rupees scooter or a 10 lakhs rupees of car cannot add in another 1 lakh for IoT. In fact, those kind of advanced technologies, or 10 lakhs car cannot become the price of 20 lakhs, because we need more computing, we need more power and all this. So that doesn't work in IoT. So we need to figure out the price sensitivity, power sensitivity, the processing sensitivity, the place, and definitely the proportions and everything. Like we are talking about micro devices, mini devices, and the sizes of those are very, very small and all this. So if you see, those are the initial 5 basic constraints, where it doesn't go through whatever you have learned in the last 1 or 2 or 3 days of quantum era computing. It doesn't go with that. Another thing what I would like to talk is basically, when we not only talk about this thing, we are also talking more low bandwidth, high latency, intermittent connectivity. The connectivities are also not this. So all this, basically what we talk in IoT is a constraint device, constraint network, constraint data, the element, constraint in everything. When I will tell you a protocol, you might have heard about it. It's called CoAP. So CoAP is a protocol which is a miniature version of HTTP. You know what, in the industry we talk CoAP as poor man's HTTP. Basically, HTTP itself in IoT is not a recommended protocol, because it's a very heavy protocol with a very header size of 1024 bytes minimum. It has got a lot of what you can say, like power hungry, processing hungry applications and everything. So those itself are very higher end. Now when we are talking about IoT devices, imagine why security is a constraint. The security was not a constraint because the technology was not available. World technology is very much available. When we talk about, let me give you an example. When we talk about quantum computing and the security, a lot of people, when we go to different seminars and all this, recently one of the guys from the other side, on the security side, he was talking about that, Tushar, like the way you guys are sending your passwords, the way you are doing the handshake, you are just sending a password, login IDs and everything, sharing keys and everything. Even if you are giving it, suppose, a 12-character password or 20-character password, at this particular moment, it might take several months or years to break. The moment the quantum computing, that entire piece of work gets implemented, that password mechanism will take how much time? Maybe 3 minutes, maybe 3 seconds. So those kind of things people are talking about. But whereas even in today's world, when we talk about security and everything in IoT, we are very, very limited, because the devices where we implement those securities, they cannot even do a 256-bit encryption with AES. They still go ahead with certain protocol integrated security mechanisms. That's why the challenge. It is not the question of technology. It is question of processing ability. It is the question of whether that existing protocols of security can be managed within that low power devices. No. So that's the challenge. So the challenges in the IoT is a little bit different. Unless and until we understand that, getting excited about certain very new technologies will be a little bit challenging. We'll be getting into a different direction. Okay. Pause me if I'm anywhere. I'm just certain things are not clear. Okay, I'll just go to another one. I'll not go through all of this, because constraint in various challenges. Like when we talk about scale, we talk about security, device networks. There are multiple things. I'll not go to that those things. Because I have already explained you, like what are the different things and everything. I'll just talk about a simple example now. I'm trying to bring in certain challenges within our mind. When you talk about IoT, I will show you in front of you into your screen. If you can see the picture of the aircraft, I mean the logo. you can see this is the kind of another side of IoT when we talk about data. So where IoT is, in fact, where quantum computing and everything can still help us is basically when we talk about IoT, yes, there is constraint, but at the same time, you can imagine there's a huge amount of data which you cannot even imagine in a normal IT level of computing. Whether you send whatever data you have in an industry or anything, when we talk about multiple thousands, multiple millions of sensors connected to a component like aircraft, the amount of data it collects on that particular time for analysis and all this, I just given you an example in front of you. All of you can see the screen. Just quickly go through that the screen, whatever is there onto that, so that you can get an idea. This is the amount of data we are talking about, that too on a constrained environment. So it gives an example on the Boeing 737. It tells that it creates 20 terabytes of engine information per hour. And it is telling that multiplied by an average of 6 hours cross-country flight from New York to Los Angeles, and you are now looking at 240 terabytes of data for every engine hour. Imagine 240 into 6 hours. I cannot count these numbers. So at one end, we are talking about constrained devices. At one end, we are talking about enormous level of data, which is either going for a waste right now, or we are not being able to compute, massage, analyze, or get the use of it. So this is where one of the biggest advantage where we are thinking that quantum computing will bring in and change this entire perspective in a different dimension. So I'm connecting now these two dots. If you have so much constraints, and on the other hand, you also require that, okay, you need to get those data to make value. How will you do that? So there is something that, let me go forward. I'll try to connect to you. I believe all of you are getting me, right? Anybody can, because I cannot see any of you when I'm looking into the presentation. So I believe, okay, everybody is audible and things are going through.
Yes,
okay.
sir. Yes, sir.
Sure. So let me take it forward a little bit. This is, so I've just given you two challenges. You can also start thinking about it. Like when we talk about quantum computing, it's a new era. We are bringing revolution to the entire thing. And we are thinking about, oh my God, how fast computing can be. It will change our entire world. AI, ML, everything will be super fast. And our output, our data analysis speed, our working, in fact, use cases will change completely. This will be another revolution after internet. So, but we are now giving two challenges. One is the constrained device. On the other hand, requirement of such bigger volumes of data. Let me see how to handle it. So when we try to implement those things, so more than in fact, the quantum computing, I'm just trying to tell you how we are accessing that, how we are thinking onto that. We are very small at this moment. If you ask me, being a solution architect, I still don't have a lot of things open in front of me on quantum computing. But when we go to the customers, especially bigger customers, everybody talks about AI, quantum computing, and everything on a daily basis, and they say, why can't we do that? So we need to be ready that onto the solution. Is there something we can do at this particular moment? So there, when we talk about IoT, we talk about two layers. So I'm not going into the IoT. In fact, what you can say, like architecture and all this, we all know there are three elements. I'm not showing it in the picture. It's the sensors. When we collect the data, then it is the communication where we send the collected data up to the cloud. And the third one is what we can say like the dashboard, or we can say the application layer where we make sense, when we try to get those data and transform the data into meaningful what you can say like output. So that is what the three layers. But when we talk about overall architecture, we distribute it into two areas. One is the tech layer, one is the value layer. What is the tech layer? The tech layer contains about all electronics, all sensors, all communication capabilities, different kind of communication where we talk about low power wireless communication. When we talk about medium distance LoRa or this kind of network, when we talk about 5G or something, anything comes onto the IoT tech layer, along with different kind of microcontrollers, different kind of what you can say like gateway devices, everything. Now on the other side, that is where the value layer comes in. We talk about the middleware and we talk about applications. And in between these two layers, the value of the IoT holds. What is the value? You cannot go and sell technology to somebody. In today's world, IoT, when we talk about IoT, IoT is a core part of digital transformation, but IoT is an enabler. IoT is not directly giving the value unless and until you enable that application layer, value layer with AI, ML, all kind of implementation. There you get the money. First is technology, and then somebody will be paying you the money. So that's why we call it value layer. So there we do all kind of software analysis, data analysis, and everything. Let me elaborate it a little bit more. Onto this tech layer, quickly going through device hardware, device software, networking. And when we talk about device, the software, if you see here, we are talking about the RTOs. Okay, we were talking about multiple small firmwares which we normally put it onto our devices. Then onto the network side, when we talk starting from 802.10 to 802.11. In today's world, when we are talking about 802.15.4, which is low power wireless area networks, and some people call it low LP WAN also, low power, the wireless wide area network, all these things we talk about. But remember, it's 802.15.4 where the protocols like Zigbee, protocols like what you can say, Sigfox, NB-IoT, LoRa, BLE. Okay, there are multiple other things are also there. Okay, so those are the protocols we talk about, and those are part of the tech layer. So one thing we have at this particular moment, we know into the tech layer, we may not get any value at this particular moment into the next 3 to 5 years from quantum computing. Yes, we are doing some research. When you talk to international speakers and everything, we see certain things, and I'll be giving you some a very good example where recently certain things have been developed and all this, but it's been a very low scale. We'll talk about that. So let me move away from tech layer. Let me go to the construct the value layer. What is that value layer? Into the value layer, when we talk about, there are three components. One is middleware, one is edge computing and machine learning, and there is cloud layer with AI, ML, and complete data analytics. So those are the area people are talking about primarily onto the cloud layer, where we talk about data analysis onto the AI, ML, and all this. If you see all these algorithms, everything, whatever we have. Right. Okay, sorry. Just keep me reminded about the time. I'm not going to see the time here. I don't know where I am, how much time I have. Okay, sorry. Okay. So, okay. Coming back to this. So when we talk about, people are talking mostly into the cloud. There is a lot of things happening, but today we'll talk a little bit that when we talk about IoT, we know that quantum computing can bring in significant value into these three areas. Primarily, a lot of work in India and abroad, everywhere it is happening onto the edge and fog computing layer. So there, a certain level of significant value into the next, the immediate future. I think we can see that things are happening. So whatever we believe that in quantum computing, how it is going to help in your IoT is onto the upper layer, which is called value layer. We'll deep dive a little bit onto those things now. Let me see. Okay. So let me tell you, let me just go through a little bit. Okay. Why we are talking about this, only these three layers? Because not only now, when this entire concept was going on in the last 3, 4, 5 years, the IoT structures, IoT architecture also has emerged in a different way. When we talk about primary 3 layers and all this, today we talk about, we moved from 3 to 5 to, today we're talking about 7 to 9 layers also. Why we are talking into 7 to 9 layers? Because of this, that how to bring in the value that this supercomputing devices, this quantum computing and everything is bringing in, how to accommodate that within the existing architecture and how to do it. So to continue doing that, let me quickly go through to the end of my slide, because I have got some backup slides. I thought I'll be showing it to you. Let me, yeah. So if you see, this is from the IoT World Forum, or we say IoT WF. What they have done brilliantly, they defined architecture where now whatever I was talking to you about the technology layer and the value layer, they've already distributed this IoT, this thing. If you don't, anybody doesn't have this one, I'll send the PPTs to you for your students, for your life also. I think practical implementation, when we do it very, very clearly. There are two segmentation of IT and OT. If you see, this is what I was talking to you. On the upper side, where everybody in India is working onto the IT, and on the lower side, we are talking about implementation onto the OT, which is we call operational technology. When we talk about operational technology, it is right onto the platform of a factory, right onto a domain. Suppose a blast furnace in steel industry. It can talk about a certain factory floor, how the assembly line is being maintained with their 5-layer architecture. When we talk about SCADA, when we talk about MES and all these things, how MES to SCADA to your device layer, how things are coming, how the PLCs are interacting and all this, entire these things comes into the OT. So there are two things when we talk. One is OT is data in motion, IT is data in rest. I hope all of you are getting that slowly. So why we take data in motion? If you are computing certain driving factors of a car, if somebody comes in front of the car and it just supposed to do a certain brake, those things are called event-based computing or data in motion in real time. If you see on the right hand side, I'm reading onto this area. Just follow me onto that. So for an example, you have some fire detected on a big building. During that time, it is, first of all, it is fire, and it's a different technology on a building, AC, building temperature and all this. If you know, this technology we call is HVAC. And HVAC connected to IT brings in the entire IoT, OT, in fact, IoT implementation, all this. So now onto the HVAC system, we always had that, but what we are trying to bring in, that event-based triggers, data in motion means immediately, it has to be acted immediately. So data in motion, and that's a real time. But on the other hand, if you go upward, when we talk about advanced computing, when we talk about IT and all this is we call data in rest or non-real time. Because if there is a fire, it has to be acted immediately. But why the fire has happened, under what circumstances, within the same circumstance, is there any kind of data element we are storing that tomorrow it should not happen, or after 5 years it should not happen? What are the elements which has participated onto that particular fire? What was the heat during that time? What are the machines? What are the electricity consumption? What was the, what you can say, like utilization of the machines and all these things? Those things can be analyzed and can do a predictive maintenance and preventive maintenance, preventive actions, that in future there is no fire. But that goes into the upper layer where we talk IT and where we talk about the value layer. But where IoT also works into a layer which is called data in motion. There we still feel that quantum computing and all these things has got a lot of limitation, a lot of these things to go forward. And there we don't have any solutions except some of the research papers where people are talking about. And I will talk to you about one of them, very silly one. Okay. This is one of the things when we talk about architecture. This is one of my design only, but yes, this is based on to all what you can say, like where people talks about how we implement. So if you remember, we talked about sensor, we talked about connectivity, and then we talked about data management and analysis. The three bricks which are onto the forward side. The first one, the two down there, and the green one. Those are the three. But to bring in all this new concept, new computational power, all these things, we have created, and we are into the industry creating that how we can distribute this computing into multiple stages. Even if we have certain things that, okay, we don't have superpower computers, we don't have very, what you can say, like battery powered devices and only, and all these things, how we can take those data into in a staggered approach, taking it forward so that we can take the value of very advanced computing. So if you see here, we have distributed into 3 and 4 additional layer. One is edge computing. Next is accumulation layer. Another onto 1, 2, 3, 4. If you see onto the 5th, there is an analysis layer and everything related to data. And onto the top, if you see, that is the value layer or the value addition. There are a lot of, so in one use cases, how many more use cases we can add into that, how we can create a complete ecosystem from one IoT use case to multiple different things and everything that we talk there. But now all this 4 additional blue layers, if you see, those are the areas we can get into certain level where we can get the benefit, get the advantage of this faster computing, the completely revolutionized computing of quantum computing, whatever we are talking about. So what we are targeting primarily into the edge, bringing in certain security through a little bit higher computing power, then definitely sending our data for accumulation, that is storage. Not only storage, there should be multiple distribution of data, multiple. When we talk about data today, we are no longer talking about only structured data, but completely unstructured data. If you see onto that MongoDB, we were talking when it came up, we were thinking like, okay, this might be a revolution, but today MongoDB is also an old thing where we are talking about voice data, different sound data, different kind of video data. Data has changed. Then image data. Today, if you see, there are assembly lines where we are doing implementation. That whenever there are hundreds of, in fact, what you can say, like items are being produced every hour or every 5 minutes, there are hundreds of gadgets are being produced on an assembly line. The moment there is in fact, some fault on 1 or 2 particular devices, we identify that onto the edge with a camera or something, we can immediately reject it, send it back to what you can say like framing and everything else. So those things, if you see, we are doing it onto the edge. Why we are using edge computing? Because every data now, I'll give you an example, like whatever we talked about that flight example. Onto that flight example, we have seen that the amount of data, whatever a flight or a car or anybody is gathering, it is not really possible to send all the data to the cloud. There is no the technology, nothing there. Even if we have, in fact, very higher end quantum computing, we are basically gathering this data. We cannot send it up there to compute. We have to consume those data as close as possible from those devices, but with little bit more power of computation, little bit more advanced systems where we can do distributed computing and all this. And that's why this entire structure is being built, that how we can take advantage of these technologies. I'll just go forward just a minute. Okay, this is some of the things which was created, keeping it in mind. I'll not just go through that. This is onto the quantum computing, how deployment cost and all these things in IoT could be done. So I'll just come back to this. So based on to everything, whatever we talked about, we have identified at this moment, when we talk it's the industry has identified that yes, the quantum sweet spot is IoT security, data optimization, and you can say data management. Third point is application of IoT AI ML for predictive insights, and definitely enhanced predictive maintenance. So these 4 areas where in fact quantum computing can definitely help us into the IoT. Before deep diving onto that, we have got very less time. So, ma'am, I think I'll be getting at least 10 minutes extra because we lost it. So I'll just move forward at this moment.
Yeah, no problem, sir.
Okay. So I will talk about quantum computers' immediate role in IoT. Okay. First is, there are certain things where people are working already. There are things that are happening in different places. Onto the security side, there are two things. One is quantum key distribution, QKD, and post-quantum cryptography, PQC. These two protocols. Okay, before coming to that, I just forgot to tell you a couple of things. Sorry, when these things were happening. When I talked about your device constraint, network constraint, and all this, if you already know that onto the technology, onto the application layer protocols also, we use absolutely different set of protocols when you talk about IoT. We don't use HTTP, we talk about MQTT. We don't use much HTTP, we talk about QoAP. We don't use Wi-Fi or something. We use some or neither Bluetooth but BLE. We use some different communication technologies which is within 1 to 10 kilometers like LoRa and everything. So now if you see, when we talk about those things, those kind of constraints, with those constraints also, we can see that those QKD and PQC, I'll not go deeper because I don't have time. This 1.5 hours, 1 hour is not enough for that. But these two things, you can just note it down for you. Later, if you want, I can just have a separate session onto that sometime if you are interested. So those are the things we're implementing into the security side. And if you see, China, I think, has got one of the satellites they have already implemented some time back. Okay, on that particular thing, they have shown that satellite communication with the sensor data with complete encryption of QKD is being done at this particular moment. Yes, it is expensive. It is not implementable or something, but you have seen that when we talk about short distance communication or something, when we moved away from satellite communication long back, we in fact thought about bringing in LoRa, bringing in application layer protocols like MQTT and everything. So merging all these things together. So basically merging all these things together, there are technologies which are there. This is these two things aspects I just want to put in front of you for the security side. Then we'll move into another thing where we are doing a lot of what you can say like experimentations and everything with the quantum computing is the role of quantum computing into the edge and onto the fog computing layer. So definitely what is happening that with advancement of quantum computing, we are being able to identify that with multiple terabytes of data, how to identify the garbage, how to identify the data which is constantly coming up only because of some running system or something which doesn't hold any value. One set of the data will be sufficing everything. Those kind of things, optimization of data, those things we are being able to do. People are doing research using quantum computing, the methodologies and everything, that how we can do this data allocation or the optimization up to that. Real-time decision making for critical application, it is still very challenging. I should say, whatever we can do, if it's in the scale of 10, can not even at 1. So real-time decision making, definitely quantum computing with connected in fact systems and everything, we can significantly change this one. We can reduce the accidents, we can reduce the, in fact, what you can say like unfortunate things, starting from a plane to a scooter to anything, in fact, a building, the security to anything, everything. With the help of quantum computing, when we are bringing those things up to the edge, if not fog, and then enhanced routing and multi-node efficiency. So when we talk about nodes, multi-node and all this, we are talking about billions and millions and billions of nodes, which is unmanageable at this particular moment. Yes, we are doing it, but at the same time, there is a lot of limitations, a lot of challenges. So those routing, intermediate routing between all this, because when we talk about IT, we talk about few hundreds, few thousands of computers, max to max for a big company, maybe 100,000, 200,000 computer for a company like Accenture and all this. But when we're talking about IoT network, we're talking about billions of connected devices. For those, the routing and all these things, there we are trying to bring in certain kind of optimization using quantum computing. The third and the most important, so this is just an element like how this entire staggering. onto the edge computing, real-time data processing, across the fog, edge and cloud, how it moves and everything. Because of the time, I'll not go through all these things, but this is where we can see significant advantage when we are getting into the era of quantum computing. People are being able to implement things for taking into the fog nodes, okay, into the integrating directly into the cloud platform. That is where people are thinking about bringing it up. So this is one of the things I was talking about. Lastly, this is where actual things will happen. So some people might say to me that this is not IoT, but where I was telling you, this is at if you take this particular piece in an isolated manner, it doesn't have value. If you take the IoT in an isolated manner, it doesn't have value. But IoT, getting the data, sending the data, processing the data, making the meaning with AI and ML, that's where end-to-end IoT value comes in. So even if significant things are changing, significant amount of work is happening onto this classical, from the classical computing to the quantum computing, especially onto the data management, onto AI and all this. This is the biggest advantage what IoT is going to have. And this has already started in a low level, but we definitely see into the next 5 years, into the next 10 years, we can have significant benefit into this area. Onto the other side, onto the tech side of the IoT, yes, there are certain challenges, but I will tell you, I'll just come quickly onto that. There are certain papers, there are certain things people are talking about are quantum sensors, miniaturized quantum hardware, and hybrid architectures. So due to the time, instead of elaborating all these things, you guys are also looking into those things for a long time. You can connect to me. I can just talk about all these things into pieces, into elaborate things. I'll give you something that when we talk, I don't have time to go deeper into quantum sensors and everything, but this is people are talking about. When I see today in my, till the time I'm in the industry, I don't think I will be able to see those things. But the way technology is changing, I don't know what is waiting into the next 5 to 10 years. If I survive, I may be astonished that when we are talking about sensor network, we are only talking about constraints and everything, it can completely change. Before I end this thing, I will talk about a little bit of a hybrid architecture. If you see the picture below, this is one of the hardware. Very recently, I'll just come to your question. Okay. Very recently, this is one of the device. I'm telling you, this is an existing device, and that I'm trying to bring in from China. Because of customs, I'm not getting a hands-on onto that. It's a bit expensive, but not very much. They have said it has got nothing to do with quantum computing, to be precise, but keeping that in mind, they are basically bringing in on a small microchip, you can have a complete Linux environment, which is not possible as of now, as of today. Within the hardware, there is a company called Xiao who are really brilliantly doing in China over the last 2 years. Every day they're bringing in amazing things, and I sometimes get astonished how they're bringing things with an affordable price and with a what we can say like practical thing. It is no longer research. They are bringing in things which we can implement. And if you see, this has got multiple sensors, everything. It has got accelerometer. It has got everything, accelerometer to everything, basically, with TFT display and all this. But this kind of computing they are trying, it is still, it's a kind of concept. It has got nothing to do with absolute quantum computing or something. But keeping that in mind, they're doing a very small baby steps, and this is happening, which I can see. So when we talk about hybrid, when we talk about classical model, when we talk about the quantum model and all this, how we can bring things together in small bits and pieces, those are the examples. So I'll stop here with this particular thing, and I will tell you, yes, future is very exciting, but don't forget, when we talk about IoT in quantum computing, there is a lot of more challenges which we have to address, because unfortunately, we have never understood that IT is not IoT or OT. So when we talk about IoT, there is a huge constraint. There is a different requirement. We don't need a lot of computing power unless it goes into the analysis and everything. But yes, when things are coming up, when advancement are happening, we would like to be part of that journey. And we are excited that there are things coming up. But that's where I'll just end here, and I'll just come back to you guys now. So I don't know how to come back and stop my presentation for the moment. So I'll just stop, and I think I'm back. Okay.
Yes. Yes, sir.
And ma'am, I believe I'm on time.
Yeah, sir.
Okay. So there was a question just now I saw. Anybody has got any queries, anything? Because okay, one thing I'd like to tell, whatever I told today, I know in the small time, two things I avoid. One is I didn't want to give you a story like, okay, this is how world looks like. I tried to bring in, like, when we talk, because why I'm bringing it, I talk to customers all the time. We are a consultant. When we go to the people, they really tell us like why we are not implementing this, why we are not bringing it without understanding where things are. So within that small availability window, within the small scope of opportunity, whatever is possible, if to surprise somebody or if to give to certain value, even it is a small 1% of the overall, in fact, we are not climbing the Everest right now, but we are taking baby steps so that people can get excited, people can implement small things, and IoT, why should we be away from that even if we have challenges? Thank you.
So there is a one question, how to address quantum noise and error correction on the design of IoT devices and networks for quantum computing applications.
Yes, so as I was telling you, normally when we do, even at this particular moment, when the sensor noises, the garbage data and all these things, we try to minimize certain time within the devices and all this, but actual calibration, we take it onto the steady layer, or where we say that steady, or you can say the computation layer. So there definitely a lot of algorithms, a lot of these things are coming up. Yes, onto the real time, you cannot do that at this moment using quantum computing or using advanced structure. But yes, onto the data which you can analyze, which you can change and everything, moment you bring it up to your machine learning algorithm, then you can start doing it, applying your thoughts onto the this particular technology. But otherwise, directly into the IoT, in fact, because if you have asked the question, maybe you have seen onto the factory flows and all these things, there is a lot of garbage data and everything. Those things are coming up. We are trying to resolve it directly onto the device or onto the edge at this moment. But yeah, we don't get any support of quantum computing at this moment. What we know that, okay, moment we send it upward, there will be something.
So there's one more question, sir. Can we use dynamic decoupling techniques?
Yes, as far as I know, it can happen. But at what level you are trying to do that, that is important. Because when we, whatever, if you see, like, whatever we talked about, even dynamic decoupling and everything, we are talking into the application side of the layers. At this moment, whatever is happening on that layer, IoT data, with that also you can do. But onto the IoT actual implementation, no, you cannot do at this particular moment. There are certain decoupling, because with your protocols also, if you see, there are new protocols onto IoT, everything, whatever we're supporting, it is all normally decoupled protocol. I'll just give you a very simple example. When we talk about a protocol like MQTT, it is a complete support it has got of a decoupled architecture. While we are sending the data, receiving the data, processing the data, nothing is dependent on each other. Okay, so this thought process is already there at this particular moment, but whatever is happening, no, onto the device or onto the protocol side, even if theoretically it is possible, I have not seen anybody talking onto that. I'll keep an eye. If I get something, I'll just immediately pass it on.
Sure, sir. Thank you, sir. Participants, any more questions?
I think they're also tired with the long session. So one thing I would like to tell all of you, like anywhere, any of you have any queries, if you feel certain things, you also have ideas like, okay, we can implement, try to create a POC try something out, that we can always do. Because like my company, what we do right now is basically we are trying to collaborate with all these different universities and all this. We are trying to bring ideas into the life. So we are implementing those things, and a lot of very good implementations we are being able to do together with the people like you, because you have those views, you have those research abilities and all this, and we know what are the hardware available into the market, how to design those hardware, how to connect it and all this, and we are being able to do a very good progress. I would like to work with all of you whenever time
So
comes.
if any for prototype projects, we can approach you, right, sir?
Absolutely. In a very big scale, we are doing it. We are doing it for BIT Misra and lot of other this thing, because government the government of India is nowadays trying to bring in, like they're telling us to connect with the universities to bring in realistic problem solving and everything, and that we are being able to do nicely.
Sure, sir. I would like to share your presentation, and as well as of your contact details, I'll be sharing with the all the participants, so that even they can contact, because many of all of them are from the academy field only. So they will absolutely need your help to get it done, like if any student projects or prototypes in the research.
And absolutely, that is where I'm working at this moment, because like I was tired of this corporate world after this 24 years. I've just left it like anything, and those are the things we are doing. I'm really excited. I would like to share through you. So any exciting projects, if I can help together, we can jointly make it.
Sure, sir.
Thank you everyone. It was my privilege to talk to all of you. In fact, whenever I come to the professors and talk to them, I sometimes feel scared. But then I know that, okay, I also get a lot of things. Hopefully, I could deliver something which is valuable to you.
Sure, sir. Thank you so much for your time, sir. Thank you.
Thank you.
Thank you, sir. Participants, please fill the feedback form. To all the participants, I have a small information, like as per the schedule. Tomorrow we have three sessions. So the session will start from 2 p.m. in the afternoon, 2 p.m. to 3:30, and 3:30 p.m. to 5 p.m., 5 p.m. to 6:30 p.m. Then we will have a test, as it is the last day of the FDP. We'll have a test and feedback session. Then we'll forward to the validatory session. So finally, tomorrow we will conclude the FDP. So I request all the participants to make yourself available from the 2 p.m. tomorrow. Thank you, everyone.
Thank you, ma'am.
Thank you, sir. I'll keep in touch with you, sir. Thank you.
Sure, ma'am. That would be my privilege.
Yes, sir. You can.